In this video, we're going to continue with the Computer Science 9618 A-Level curriculum, taking a look at how to simplify Boolean algebraic expressions. So these are the rules. I took this from page 355 of the Computer Science 9618 textbook. These are very simplified and, unfortunately, Cambridge is not going to give you things that look this easy, but we're going to be applying them today. The two you need to focus on are the distributive laws. Cambridge loves to use those. They also love to use the absorption laws. Those are two of their favorite. Almost every single problem that you're going to get, if you can distribute out or factor out the common factor, if you can use the absorption laws and apply those, you'll be able to get it through any Cambridge problem they give you. I also have a bonus problem at the end where we're going to do De Morgan's law, looking at a Cambridge question that looks absolutely brutal, but it's not, because I'm going to break it down and make it nice and easy for you. So let's go ahead and start with the very first problem here. In our first problem, we have A not C, or B not C D, or A not B C, or A C D. I'm not going to say all those ands, that would take forever, and we're not going to write the dots. We'll do that at the very end. When I'm doing my Boolean algebra, the first thing I want to do is ask myself, okay, is there something two terms have in common where I can apply those Boolean algebra rules? That's what you're looking to do. And you can say, oh, this one has A and C in common, but there's no point in factoring those out. That's because I can't do anything with this not being D. There's no Boolean algebra rules to apply there. So there's nothing I can do with that. Now, there is something I can do with this last term and this first term where I can apply some Boolean algebra rules. They both have A in common. So I factor out that A. That leaves me with not C or C, D. Now I can apply the Boolean algebra rules. Here I'm going to use the absorption rules. We have a complement. We have not C or C. When you have not C or C with something else, the one by itself always wins. And you're going to see that again and again throughout this video. So the not C is the one by itself. This C loses. So then all we do here is we distribute it out. We have A not C or AD. That takes care of these two right here. Those are done. All I need to do now is write the rest of it here. Now I start looking to see what I can do. And again, this last term and this first term will allow me to apply the Boolean algebra rules. I'm going to factor out that A. I get that not C again, or, and then I have not B or C. I have a complement here in these two. The one by itself wins. So this gives me, so that takes care of these two terms. Because when I rewrite this again, I want to make sure I don't write the same term twice. So A not B, or AD, or B not C, D. And what I want to do is, let me rewrite this. What I want to do is I want to put in those dots. I want to show Cambridge that I know where the dots go. So put in some dots here, put some dots here, and this is my final answer. I have A not C, or A not B, or AD, or B not C, D. So when you factor out, you want to find what do they have in common where I can apply those Boolean algebra rules, because once you do that, you'll be able to solve 99% of the problems. Let's go ahead and take a look at the next question. This one looks a little more simpler. There's not as many not signs everywhere. We have B or not A, not B, or ACD, or A not C. So this one right here, I can go ahead and factor these out. So that gives me CD or not C. The one by itself wins. This not C is by itself. This C loses because it's attached to something. So we get rid of this. Now we have A D, or A, not C, and I want to bring these two terms down, B, or not A, not B. Now, right here, I have an absorption rule that I can apply. The 1 by itself wins. This B is by itself, it wins. This B loses. So now I have B, or not A, or AD, or A, not C. Well, right here, I have an absorption rule. The 1 by itself loses. Or I'm sorry, the 1 by itself wins. The one that is not by itself loses. This A is not by itself. It loses. I could change the entire outcome. So we have B, or not A, or D, or A, not C. Now, this right here and this one right here, we have complements. The 1 by itself wins. The one that's not by itself loses. So we get rid of this. And now our simplified expression is not A or B, that's these two, or not C or D. And this is my final answer. So that one, there's complements all over the place, and you just keep applying it till you can no longer apply any more algebraic laws. Let's go ahead and take a look at the third example. All right, in this example, we have not ABC or AB not C, or ABC or not ABC. When I'm looking at this, I notice something right away in the first and the third term. I notice I can do something with this A and this not A. I'm going to factor out the BC. Make sure it actually writes. So here's my not A or A. Now these two do not cancel each other out. This actually simplifies inside the parentheses to 1, which simplifies the BC. Now let's talk about why that's the case. It's not just so much knowing the rules, but being able to apply and understand the rules. If everything inside this parentheses works, and it does, because if A is off, it works. If A is on, it works. If A is a 0, it works. If A is a 1, it works. So inside the parentheses, all solutions are possible. Well, if all solutions are possible, it doesn't matter what I do, it's always going to work. So I don't even need them because I have B and C that I also need. So that takes care of this first term and this third term. So I do BC, and I'm just going to rewrite it again. I want to have my updated Boolean expression, and I definitely want to make sure I'm showing Cambridge what I'm doing. Now when I look at this one, I start saying, is there something that these two terms have in common? And right here, I can do something with these two terms. What do they have in common? They have B. Factor out that B. I'm going to do my C or A, not C. Because remember, I'm factoring out this B here. So I'm left with A, not C in the parentheses, or with the original value, C. The 1 by itself wins. I get rid of this. So this simplifies to, I'm going to write it in order AB. So that's A and this B. Then I'll do the BC. Or not A, B, not C. Now in this one, you'll notice they both have a B in common. I can't do anything with these two yet. If I factor out the B, I'm going to get A or C. There's nothing I can do here. So I take a look at these two terms right here. So I have AB, or, and this is going to be B, and I factor out that, or I distribute the B to C, or not A, not C, not the B one. So not A, not C. Well, the 1 by itself wins. So now I'm left with AB, or not AB or BC. I can do something with this right here. I do the B. I get A or not A again. We know that comes out to 1. So this gives me B, which is these two terms right here, or BC. This is the absorption rule. I can apply the absorption rule straight to here. If I have to have B or B and C, I don't need C at all. Because if B is a 1 here, if B is a 1, and I know I need B and C, well, B is going to be a 1 in both cases, so I don't need that C. That's just going to cost me an extra expense because I'm going to need to buy an AND gate and have another input. This simplifies simply to simply B, and all I did was apply the absorption rule. When you have this, there are no complements, but that is the absorption rule, and it simplifies to just B. Let's go ahead and let's take a look at the next Boolean algebraic expression. All right, this one looks a little, it can seem a little overwhelming, but it's really not. All we're going to do is rewrite this with applying the distributive law. That way we actually can get rid of some of these parentheses and see what we can do. So when I factor out or distribute this, I keep saying factor out, we're distributing this not A. I get not A and A or not AB. All right, that takes care of this. That takes care of this. The next thing I have is this, I need to FOIL here. So we FOIL, which is front, outside, inside, last. So that gives me AB. That's the first thing here. So this is the F. Then I need to do the outside terms. These are the outside terms. So that's B, not B. Then I got to do the inside terms. You should be familiar with FOIL. If not, there you go. And then the last terms. And this is double A, or A and not B. Okay, so let's talk about, let's go ahead and simplify this down even more, applying those rules. So right here, we have the inverse rule. Now, if I have to have not A be 1 and at the same time I need A to be 1, we know that's not possible. We know that is not even remotely possible because I can't have, well, I have two not A's here. I can't have A be 1 and also the same time not A be 1. Because if A is 1, then I know that not A must be 0. It's just like when we did those flip-flops with Q. If we know if Q is 1, then we know not Q is 0. If not Q or not A is 1, then we know the inverse, the other one must be 0. So A cannot be on and off at the same time. So this is 0. Well, we know 0 or anything else. This simplifies to anything else. So we just get rid of this. Now, looking at the next one, here I have a complement that I can apply right away. I know this simplifies to B, A, or A. Now this comes out to 1. So we have B1, and that comes out to B, and I'm going to write the rest of this right here. Now we know B and not B are not allowed. We know those simplify to 0. That's not needed because B or 0 just comes out to B. Here we have A and A and A. This simplifies to A because you only need one of them. You can't have 3 inputs. I mean, you can, but if they're all equal to one another, you only need one of them. And then we have AA, not B. Well, here again. Now, when I'm looking at this, I see here in this first and this last term here, I can apply that complement rule. So we have, we don't need to factor anything out when it's B or A not B. The one by itself wins. So we're left with B or A or A. Well, I know these simplify to simply A, and I'm left with A, B, or A, or I could write it as this. Cambridge will accept both. A or B. Because of the associative laws, I can flip it around if I want to. So either one would be acceptable. So even though, yes, D looks overwhelming, by simply breaking it down and doing it one step at a time and applying those Boolean algebra rules, you're able to simplify and get it in its simplified expression. Let's go ahead and take a look at the last example and then a couple Cambridge questions. This one can look a little overwhelming at first, but all we're going to do is we're going to rewrite it and see what we can do. So the first thing I need to do is I need to do the FOIL method. So that gives me AAD. When I multiply those front terms, I get AA not D. When I multiply the outside terms, the inside terms are going to be ACD or ADC, however I want to write it. And the last terms are AC not D. And then I have AC or C. Well, I know right away, applying the absorption rule, this comes to C. So those two terms are handled. What about this AAD? What about that? Well, I know this simplifies to AD and this one simplifies to A not D. So I can simplify those, and I'm just going to rewrite it again. I want to show Cambridge all my work. Now, the next thing I notice is I can apply this right here. If I factor out this A, I get D or not D. Well, I know that's 1. So now I have this whole thing becomes A, and I'm just going to keep bringing those terms down. So AC, not D, and I see the next thing that I can work with, which are these two terms right here. I know that I have A, and if I do, they both have AC in common. So if I do AC or AC distributed to D or not D, that comes out to just AC or C. Now here you get something that's interesting, and I want to point this out. Here we have the absorption rule. I can do this one, or I can do these two. You only get to pick one. You don't get to pick both. And it doesn't matter which one you pick, because by the associative law, both of these will work. It doesn't matter if I do A and C, or if I do A and C or C. For example, if I do A, so let's go ahead and do this one. We know this simplifies to A or C. But if I decide to do it the other way around, and I say, you know what? I'm going to simplify these two. Well, we know that this one right here simplifies to C. We bring that A down, and we're left with the same result. So this one is simply A or C. Let's go ahead and take a look at the Cambridge past exam question, where we can apply everything that we've practiced so far. So we have not A, not B, not C, not D, or not A, not B, not C, D, or not A, not B, C, D, not A, not B, C, not D, or not A and B, not C, not D. We have all of these. So Cambridge just looks like they put almost did every possible scenario here for these nots. And we are not going to let that intimidate us. We're just going to walk through, break it down one by one, and pick up all 5 points for this exam question, which is almost 10 points of the total points you can earn. It's 75 points is the max, so getting 5, that's almost 10%, not quite, but an easy give me 5 points, and we'll take those and raise the minimum passing points needed to pass the exam. All right, anyway, here we go. So looking at these two terms, I can do something with these two terms, that D and that not D. Well, I know this factors out to not A, not B, not C, not D, or D, and that comes out to 1, so we know this is 1. So we have not A, not B, not C, and remember, multiplied by 1, if I do this not A, not B, not C, 1, well, then I know that 1 is not needed. So that simplifies to not A, B, C. Now I have these, that takes care of these two terms right there. So I'm going to check those off. I'm left with these three terms. Looking here, I can see that the not A, B, C, though these terms right here have those in common. So I'll go ahead and factor that out, not A, not B, C, and then I can apply that D or not D. And like I said, Cambridge loves doing this. So this simplifies to a 1. So we're left with not A, not B, C. That takes care of these two terms. And then I have not A, B, not C, not D. So I haven't really done a whole lot, and already I simplified it to something much more manageable. Let me go ahead and switch colors so as we walk through this, we know what we still have to work with. Looking at this, these two terms right here, I see that they have not A, B, not A, not B in common. That allows me to do something with these C's. And I want to show Cambridge, I just don't want to skip this step. I want to show Cambridge that I know what I'm doing. So this is that not AB. I want to show that this equals not AB. So not A, not B, 1. And I know that simplifies to not AB. And then that takes care of these two terms. I'm left with not A, B, not C, not D. So when I'm looking at this one, I know I can do something with this B, these B's right here. So I'm going to factor out that A. So I'm going to switch colors so we can see what we're doing here. So I have not A. Then I have my parentheses, and I can do that not B or B, not C, not D. Well, the one by itself wins, so I get rid of this one right here, and that leaves me with my final answer, not A, not B, or not A, not C, not D. There's no more simplification I can do here, and just like that, we pick up a full 5 points on our exam. Now, let's take a look at a past exam from very recently that uses De Morgan's law, and it looks brutal, but I'm going to walk you through it and show you how easy it is to solve. All right, so they want us to simplify the expression using Boolean algebra, including De Morgan's laws. We can do that, not a problem. So what we're going to do first is we're actually going to handle this part of the not, which corresponds to these AND gates. And if it's not AND, we know it's got to be OR. So we have AB or AC or BD. Now what I need to do is I need to put in these next, all these bars back in. So we had a bar above AB because we haven't handled this one yet. We had a bar above AC. We haven't handled this one yet, or this one, and a bar above BD. That first bar has now been simplified. The second bar, well, that's over AB. We have a bar over AC, and we have a bar over BD. And then getting to this last bar, I have something over A, something over B, something over A, and nothing over BD. So I can simplify this. Look at this part right here. These cancel each other out. So here I have AB, I'm going to put those bars back in because I can show this one step at a time. So what do I want to handle next? I'll handle this part. I'll handle this part right here. Those cancel each other out. So I have not A, not B, because if it's not, well, then it has to be, they cancel each other out. Same thing here. These cancel each other out. And now I have B, D. So that is everything simplified, but Cambridge is going to want me to go one more step. Right here, they want me to factor out this A and use the distributive law. So that's not B or C or BD. And that will give us our third and final point. So even though, yes, this looks extremely overwhelming, by breaking it down, we can do that. And I want to look at the last problem. Yeah, see, I forgot to do that. So we can factor out that A. So the final answer would actually be this, because Cambridge wants us to use the distributive rules. So this would be not C, not D. There we go. So that would be our final answer. And then here, I remembered to do it. So I hope you guys found this video helpful. Hopefully that makes Boolean Algebra a little easier to understand. We looked at several practice problems. If you did find it helpful, please give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next review video.